Howdy, my name is Sammy. I'm the CEO of Team Amazon, and I was mainly responsible for designing and implementing our system architecture.
Howdy, my name is Abel Guzzo. I'm the CTO. I'm in charge of data collection and make sure it's done ethically.
Howdy, I'm the Chief Artificial Intelligence Officer for Team Amazon, and I was responsible for the ethical use of generative AI throughout our project.
So to go over our problem, basically, we created this AI-powered data breach hub to solve the problem of many different data compromises that are happening as we speak. This year, we've had more data breaches this year than in years past, and as you can see from the graph on the right, as soon as Gen AI became a thing in late 2022, data compromises have nearly doubled every single year and is continually to increase. And the thing is that with our product, what we're planning to solve for is to basically take all these data compromises and basically collect all of them such that you can give it out to any sort of individual developer, or anyone at a company. And this, and because of all these data compromises, this is creating a high threat environment for everybody that accesses the internet. So to bounce more off of that, basically, like I said, there's lots of different data compromises, and they're actually in a lot of different places. There's the main web and deep web, and also in the dark web, where there are lots of data that are fragmented out, and it takes a lot of time to report these data breaches and report it such that it comes very quickly, and then you can patch those vulnerabilities as quickly as possible. And because they're delayed and inconsistent, it makes it really hard to track all of these different data breaches that are coming out. And like I said, with AI that came out in late 2022, is pretty much a force multiplier, allowing for attackers to launch more sophisticated attacks, and more vulnerabilities have come out because of it. And because of those more sophisticated attacks, uh, a lot of targets such as universities, hospitals, companies, startups, etc., have continued to go under pressure, and more attacks have been happening because of these data breaches.
So, in order to bridge this massive delay of important information that exists in our cybersecurity landscape, our solution was to create one unified AI-powered data breach hub, kind of like a one-stop shop wherein all information we scrape through our various tools is then aggregated, classified, and appropriately labeled and synthesized into clear public data breach reports or security incidents. And our main goal with this was to make it visible, so giving open access without the user having to worry about any privacy concerns. Before we even began designing our solution, one core requirement for us was being ethical throughout it. This was especially important due to our motivation for the project. We needed to ensure that we were part of the solution and not contributing towards the problem. This meant that all information that would be present on our dashboard would be publicly available and from legally accessible sources only. Furthermore, no confidential information or personally identifiable information, PIIs, would ever be stored, shared, or collected. We wanted to be the solution and not the problem.
So for the solution deep dive, I'm basically going to be going over our entire system architecture for our solution, coming from the inputs all the way to what we show the users. So to start off is that we have three main data sources that I kind of talked about, which was the main web, deep web, and dark web. In the main and deep web, this contains a lot of news sources, or maybe the companies come out with a report that describes exactly what happened and maybe even breaks it down. And then in the dark web, what happens in the dark web is that there will be some hackers that will literally post on the dark web saying, hey, I just took financial data from Visa, for example. And what we do is we take all of that data that comes from those three data sources, and we collect all that data through a LLM web scraper, which we run once a week via script AWS Lambda. We run all this through the Amazon cloud. And then what happens is once it collects all that data, it's going to store it into our data lake, which is in AWS. And then after that, we back up that data store in case our main data source, our data lake, gets breached. We have a backup just in case if that were to happen. Then after that, we send it to three different data storage solutions. So first thing is we send it to our NoSQL database, which is our document DB, which basically helps classify and basically organizes all the information for each of the data breaches such that we can create analytics from that, which continuing off of that is we send it over to Elasticsearch, which is a graph database, which helps out with reading very quickly all the different analytics that are based on the different data breaches. Then lastly is we also send it over to our Elasticache, which if a user were to visit a data breach, click on it and view analytics, it would view it again based on them viewing it already. Then lastly is with the users, they basically will view our front end, our Streamlit dashboard, which will contain all the different analytics that would be for each data breach and basically represents a search engine that is for data breaches.
Howdy. Let's go over the impact of our solution. First, it's open source. So any individual or group can use it for their purposes. We want to help the community, to help prevent these attacks and help companies and individuals come up with better policies. Moving on to our second is fast search. By sector, country, or severity trends, you can get actionable insights to update previous code and policies. This will help companies learn from mistakes from the past and hopefully protect our data. Let's go over some key takeaways. First, it's a 360 lifecycle. From collection, classification, storage, search, and our dashboard. This cycle continues happily and continuously, allowing it to be scalable horizontally and vertically. Also, any internal tools can be added on top of this lifecycle. Moving next to our tech stack. We use Gen AI powered scrapers. It's a open source called Scrapka AI. Also, to our Temu AI chat model. Every A&M student has access to these models and API keys. Because of them, we were able to stay under our budget, $0. Very thankful. Next, we use AWS services. Even though we are Amazon team, AWS is reliable, and once you get over that learning curve, there's a lot of tools you can use and rely on. Combining all these tech stacks, we are able to create a single source for real-time breach intelligence.
Now for our live demonstration. This is the homepage of our website. Here you can see that we have tried to create something that would be usable and accessible for the biggest audience possible. We have features that could make the user lives better with light and dark mode toggles, a top navigation bar that shows the repository, recent incidents, and the team information at the bottom, as you can see over here. Furthermore, we have also adopted a simple search engine design. So over here, if I were to toggle the healthcare section, then you could see all the searches that are there for healthcare. And you could look further into any one of these searches by clicking on them. And you could see who the threat actor is, the confidence score, and the records affected by the incident. It also shows a summary and the source and the timeline for the incident. Furthermore, we have a carousel at the bottom that shows the top incidents that are happening, and also a severity breakdown, and just other analytics if you want to go deeper into it is from the dashboard over here, where you can see who the top threat actor was in the records we have, the risk score, the confidence, and the total breaches breakdown. That's pretty much it for our live demonstration. Thank you to our great sponsor from Amazon, Deepesh Kumar, and a special thanks to our esteemed capstone mentor, Professor Shreyas Kumar. Thanks, and gig 'em.